The overall goal of the following experiment is to use magnetic resonance imaging, or MRI, in a multicenter setting to evaluate deep vein thrombosis, or DVT. This is accomplished by first inserting an intravenous line into the subject and positioning them into the MRI scanner. Images are acquired using two methods. The first method, called direct thrombus imaging, evaluates fresh thrombus using a 3D T1-weighted gradient echo scan. The second method, MR venography, is performed after the injection of a long-circulating contrast agent and then imaging with another 3D T1-weighted gradient echo scan. This method allows quantification of total thrombus volume. After images are acquired at various imaging centers, they are transferred to a dedicated central core laboratory for analysis. The results show that this approach for imaging deep vein thrombosis is feasible, robust, and reliable, with excellent inter- and intra-observer reproducibility and minimal bias between two separate observers.
So this study shows a method for using magnetic resonance imaging to evaluate a very serious clinical condition called deep venous thrombosis, or DVT. DVT is difficult to diagnose clinically and to quantify objectively. Traditionally, DVT is diagnosed in the clinical setting using a D-dimer assay followed by compression ultrasound. However, compression ultrasound cannot reliably detect